this is the last revision set. So the last one will have a number 3 over here. And the question number 1 for this last set is talking about gravitational field strength about an asteroid. Asteroid is spherical and uniform density, and the lines here shows of equal gravitational field strength as dashed line. There's a constant difference in the value of the field strength between each line. As you can see, those lines over here, the spacing is becoming bigger. However, each space here shall represent the same amount of gravitational field strength. And what do you describe about the field strength as the distance from asteroid increases? And the answer for this part is that gravitational field strength, the formula is G equals to gm over r squared. And in other words, it is inversely proportional to the, this is inverse square law, inversely proportional to the r squared. And I would describe that gravitational field strength decreases as distance increases. So that's why you can see that the spacing get more in distance because it is inversely proportional to the r squared. So I can tell you that of course gravitational field strength will become smaller the farther you away from the asteroid. Okay, and you have to number 2 here, draw the gravitational field at point x and y. And when you are drawing this, what I can tell you is that you have to get the direction correct here. Field strength always towards inside the object. Okay, x and y. So must be towards the center of the object. And also I can tell you x here should be shorter because the field strength here is weaker, and y will be longer compared to x because it's nearer, it is stronger field strength. Okay, and then the asteroid has a radius 1.25 to the power 5 meter. If the gravitational field strength on the surface is 0.194 Newton per kilo, calculate the mass of this asteroid. So you can use back the equation on the field strength. It is gm over r squared. And I'm looking for the mass of the asteroid, the capital M, it is gr squared over capital G. And the G here on this asteroid 0.194. This radius is 1.25. That's the radius of the asteroid. Don't forget to square it and divide by gravitational constant. My value here is 4.54 to the power of 19 kilogram. So that's how I determine the mass from gravitational field strength formula. Okay, let me proceed on to find to give you the more solution. Io, Ganymede, and Europa are 3 of Jupiter's 4 Galilean natural satellites. The table show or lists some physical property of moons, these 3 moons, and you have to calculate the maximum gravitational force that maximum Europa exert on Ganymede, the farthest of the 3 moons. Okay, how do you do this question? You have to understand a few things. Number 1, perhaps firstly, if this is Jupiter, you have to know that maximum force happens when the distance between them is the smallest. Remember that the smaller the distance, the stronger the gravity. And if you look at the orbital radius on Europa and Ganymede, you should see that Europa may be here and Ganymede should be slightly farther away, which is about here, G for Ganymede. Okay, so what's the distance between them? So you have to analyze in this case here. The orbital radius here is given with respect to the Jupiter. Just to say, Jupiter to Europa is 6.71 to the power of 8. Whereas for Ganymede it is 10.7 to the power of 8. And you have to ask yourself what is the difference here, So you can take the difference. That is the shortest distance between the 2 moons and will give you the maximum gravity force. Alright, how do I do this question? Just we use the gravity formula, a very powerful formula. And you have to plug in the value of the masses of these two moons. Io, the moon is 4.87 to the power of 22. And Ganymede, the biggest moon, is this. Okay, and the shortest distance between them is you have to take the difference, yeah. So you can take difference over here, 10.7 minus 6.71. This whole thing actually to the power of 8. Yeah, so this is the difference in their distance, and don't forget to square it and check it yourself. You should have answer 3.04 to the power of 18 Newton. Right, I'm showing you the solution, and by any chance I'm making a mistake, please do tell me in the class. Okay, so that's how you answer them. Maximum force happen when the shortest distance occur between them, yeah. And minimum force happen when they have the greatest R. So you just have to ask yourself. Okay, question number 3. You have planet Neptune, 8 moons, smaller than a Triton. Inside a spacecraft, the rest of the Triton's surface is 10 kilo mass hanging from spring balance. The spring balance measure force in newtons. What is the reading on the spring balance when the spacecraft is on the surface? If on the surface, what's the reading on this spring balance? Yeah, it is actually hooking on this one thing of 10 kilogram mass. How do you find that force? You can use the gravity formula, or also you can perhaps find the gravitational field strength on Triton, G on Triton. You can Gm over R squared, and you have to know the mass of Triton. Given the question here, Triton 2.14 to the power of 23, and the radius on the surface of Triton, it is 1.35 to the power of 6, and square it, you have it to be 7.83 Newton per kilo. Okay, that's the G, the field strength on Triton. Okay, if you want to convert this field strength to a force, you can later on understand that your force equals to ma. In this case, the a here is the G. In any essence, this is actually W, the force of gravity. Okay, it is 10 kilogram of mass times 7.83. 78.3 Newton is the answer. Okay, 78.3, yeah. Okay, and you can actually use F equals Gmm over R squared and get the answer straight away. In any essence, they are the same. Okay, part B. Now you have the spacecraft taking off and in circular motion about Triton, constant altitude, yeah. What is the gravitational field strength at this altitude due to Triton? So it's same formula, gravitational field strength, but the R now changes, yeah. Okay, mass of Triton, that one you cannot change. Mass is same, yeah. We are talking about the same object, but the R right now, just now we realized 1.35 to the power of 6. This is the radius on the surface. Now your altitude from the sea level, yeah, or from the ground, plus 2.70 to the power of 6. This is the correct R for question B, and square the entire thing here. You have 0.870 Newton per kilo. Now this is the answer for different altitude. And you have another moon of Neptune called Nereid, orbit at a distance 5.5 power 9 from Neptune center. Nereid takes 360 Earth days to orbit Neptune. Find the mass of Neptune. Alright, this one you can use the Kepler's third law. This is in your formula sheet here. Okay, Kepler's third law, remember this capital M is always referring to the larger mass of the two objects. Okay, and the larger mass, of course, Neptune and the moon here. Moon is Nereid, larger object is Neptune. So you can find the mass directly using this equation, just rearranging M to be the subject, and you shall have this as your formula. And let us plug in the value. Okay, use a different color. Okay, and what is the R? R here is from the center, so it is safe to use 5.50 to the power of 9. This entire thing cube it. divided by gt squared. This is g, and t here is 360 Earth day here. 60 times 24 hours, 3600 seconds per hour. This entire thing square. Yeah, this is t square, yeah? And the value 1.02. Oops. 1.02 to the power of, in this case, 26 kilogram. You can always ask yourself whether this number makes sense or not. Okay, this is certainly heavier than the Earth, and it is in a safe range. You get something similar to Earth or smaller, you are definitely wrong. Okay, so always ask yourself, will you get your answer to be logical? Okay, now, in Neptune is position Z and not to scale. What is the gravity force you experience due to Neptune alone? Okay, what's the force of gravity due to Neptune alone on position Z? So we can look at here. Okay, so Z over here. So you need to know the distance between the satellite and the Neptune. And what you given over here is that you have radius of Triton about the Neptune. So this is given. And the distance here, you have to subtract the radius of Triton, you have to subtract the altitude. Okay, and by the way, I believe there's a minor mistake. Okay, this is the diameter, it should be twice. Let us follow the radius of Triton to be 1.35 to about 6. So I said the distance from satellite to Triton, satellite to Neptune. Just take the radius of Triton, which is the x, for example, minus the radius of Triton minus the altitude. That's the correct R. And move on to that page. Okay, find the force of gravity. Always start by writing down the formula. There's no harm in that. Okay, capital G is a constant, and first of them is larger mass in this is Neptune. Neptune, just now I have it to be this. Mass of satellite refer to the information at the front page. It is 2000. And the R here, this is why I say the most complicated part. Take the orbital radius of Triton, subtract the radius of Triton, and subtract the altitude, because that is the proper R. Okay, so after minusing all this, you then proceed by squaring the number. You have it to be 112 Newton. Okay, a small value for object really far away, even though the mass is huge. Okay, next you have aircraft. Aircraft here is 5 about 4 kilogram. Fly is horizontal circle, radius of R, wing tilted 35 degree to the horizontal. The speed of aircraft is 250 meter per second. So you need to know that this one is 35 degree. Okay, and then one of the problems is that the diagram is not that nice here. You should know that the wing and lift shall be always making 90 degree, and it is not so in your diagram. So lift and wing should be 90 degree, and you do know that from the question, horizontal to the wing 35, which leave the remaining here to be 55 degree. Okay, main issue is that it's not really drawn properly. Regardless, we have to solve this question. Number 1, what's the magnitude of the vertical component of L? And how do you answer this question? Yeah, it is your L here, you can resolve it upwards, and you resolve it upwards is L sine of 55. Okay, and this L sine 55 is the vertical component, and it must be equals to the W, yeah, because they're having a constant altitude here. So what's the magnitude of vertical component? The vertical component here, L sine 55 is the vertical component. Let me call this as Ly is equals to W equals to mg of the aircraft. And the aircraft here, the mass is given. Therefore, it's So it's 5 to the power 4 times 9.8. The answer here is 4.90 to power 5 Newton. So that's the answer. Okay, so the vertical component L here, which means L sine 55 balance, is W. So the vertical component is equals to W. And how about the magnitude of L? So just now I've had an expression already. If my L sine 55 is equals to my W, now I can figure out my L easily by dividing my W equals to, dividing my W with sine 55. Which will give me the answer of 5.98 power 5 Newton. Alright, and then moving on to horizontal component L. How do I find it? This one, if you look at the diagram, the horizontal component, just now we have L sine 55 for the vertical. Horizontal shall be L cosine of 55. So L cosine of 55 is my horizontal component. Okay. It's difficult to draw. L cosine 55 is the answer, and my L just now I have it 5.98 power 5 and multiply by cosine of 55. My value here is 3.43 power 5 Newton. Power 5 Newton, yeah. And lastly, use the second law of motion, calculate the centripetal acceleration on the aircraft. Okay, how do I do it? Yeah. Remember, my L cosine 55 is equals to my FC, is equals to my MA, yeah. And this A here is the one responsible for changing the direction of the aircraft. That makes the speed to be the same, just changing the direction. Okay, how do I do this? My A equals to L cosine of 55 divided by mass. Okay, this is AC, centripetal acceleration. And L cosine 55 will refer to the answer in C, which is at the top here. Is 3.43 to power 5, and this aircraft, we already know that the mass is 5 to power 4 kilogram. Okay, so 4 kilogram. My answer is 6.86 ms minus 2. Okay, and from there, how do I calculate the radius of the circular path? For this part, I think you can use this v squared over r. Yeah, so you do remember this. Find the radius of the curvature, the radius of the circle. I just take v squared. I have to divide by my AC. If you refer the question initially, the speed of this aircraft is 250, yeah, and square it, divide by AC 6.86. I will get my r here to be 9.11 to the power of 3 m meter. Alright, and I have a final question, and let's do this. A humpback bridge is constructed such that radius 50 meter. What's the maximum speed that motorcyclists can travel across the bridge without lifting off? So it means that this one will put a limit that if you move to a certain speed such that the normal force here is 0, the person will not feel the force from the seat, yeah, just about that point. So you have to construct the FC equation here. So if the person is here, remember you have always the force of gravity, and in this case the force of normal is upwards. And to form the proper FC equation, towards the center is the bottom, so your W must be larger than your N. So form this correctly, and then you tell me that N equals to 0, yeah, because without lifting off the bridge, N equals 0, which leads to FC equals to W. And then you expand the term. mv squared over r for the FC, and W is mg. So finding the speed, you can simplify, you get a third of Rg. Radius of this hump is 50, G is 9.8, and to be honest, I do not know what is the answer. You can figure out yourself. Main point, you have to get this correct, and you have to then tell me n is 0 based on the question. And from there, I deduce Fc equals to W, and my limiting speed before the guy will lift off is third of Rg. So in the end, please leave your answer in 3SF. Thank you.